Okay, in this video, we're gonna continue from Lab 8 from the pin joints, and here we're gonna create the ball joints. Um, it's the ball and the socket joints. The real thing is like this, and in our model, this connection here between the screw and the link, and it's kind of like a ball joint, and it acts like a ball joint. Even though in the real thing it can rotate only on, I guess, one direction. However, it can actually rotate on three directions if you can yank this thing. However, it's restricted by the pin joints. So it's the same here. We have the pin joints that will restrict the grip from moving out of plane. So we're gonna give this joint full rotational freedom. It's gonna be a ball and a socket joint, okay? And this C bar here represents the screw. And the screw, how do we model this? As the screw is set at a certain distance, it's like welded on the jaw handle if you don't adjust that screw. So we simply just attach this screw to the jaw handle mesh using a RB2, a spider. And that's a rigid connection, so we don't have any bushing there. We do have a bushing between the link to the screw, and that'll define as a ball and socket joint. So next step is a little bit different. We're gonna create a C bar first to represent the screw. So turn off all the 1D, and we only work on the jaw handle. However, if you remember, when you insert a node, you have to attach or snap to the CAD. So let's turn on the CAD. We need a node at the end of the screw and two ends of the screw to represent that. So we're going to insert node and click on this edge. That's the center of this circle and the center of this circle. And the other one is in the middle of this cylinder, the end of this jaw handle. So let's turn off the screw so we can see that. Okay, that's the position of this node, and this is gonna be in this point dialog. We want to insert between 2 points. Okay, it'll between the center of this circle and the center of this circle. So if you say F8, that'll be right in the middle of the cylinder. And OK. And OK. Now let's go to wireframe. Okay. We should have a node there. Oh, it's here. Okay, I made them bigger in the slides so you can see that. If you want to change that, we can go to Preference, Model Display, and here the marker is your nodes. So you can change that to asterisk for the marker. If unattached is the nodes like this. It's not attached to any element. You can make it larger, apply. That's how I made this. Okay. So usually you don't have to do that. And next, hide the polygon. So those three nodes are the for the screw. So we're gonna insert element C bar. So this will be a bar here, and this is a different diameter from the other pins. So we need to create another collector from this to that, and the next section is gonna be added to the first section. So add to existing. Okay, that's the screw. We need a node here because we need to attach this screw to the threads on the jaw handle. So how do we do that? We need to turn on the jaw handle, and we have a node in the middle. we have nodes on the face of this mesh, which is perfect for a spider. So 1D connection, spider, this jaw handle. Let's see if we have that collector for the jaw handle. The center node, it's hard to see, so probably you can just turn off that. And there's a node in the middle. It's not showing because we turned that off. So we can go to model display and let the marker show as asterisk. So it'll look a little bit messy, but you can find the node. So RB2 source is in the middle, and target, well, change this collector to jaw handle first. Target is gonna be on the cylinder, and you can try with feature angle nodes. And look at here, it's a small angle here. So this angle is actually smaller than the angle between those faces on the cylinder. So if you have an angle smaller, like you can pick those up, it'll bleed over to the handle portion. So we want to contain the selection within this cylinder. The best way I find is just to align the cylinder better than the box selector. And it's gonna have a warning because see that source node is in the middle of selection. So, oh, and it's on feature angle nodes. Well, it has to be on no method. Let's do that again. F8. Okay, it's not aligned to XYZ, so I'm gonna change the orientation and no method box select. And it's gonna say, okay, you just pick the target nodes in the pick a source node in the target nodes. So I'm gonna delete that. Okay, so I know that, and then as you can see, it's not there anymore. Jaw handle, okay. All right, so that's the spider for to attach the screw to the jaw handle, and since they share the node in the center, this is a rigid connection. And on this end, however, we want to have some rotation degree of freedom. That's why we need to insert another node here for the link for the other side. Then we're gonna tie these two nodes together using a bushing. And okay, so we have two nodes here. One is rigid connected to the C bar. The other one is going to be rigid connected to the link. Then they're gonna have degree of freedom in between using a bushing. So turn off this, turn off the C bar. We can turn off everything. And the link. Alright, so we're gonna create another spider to grab these nodes. It doesn't matter really, and it was approximately those nodes. You can argue that it's not sitting on all of those nodes, but we're looking at the problem from the whole model perspective. So if you want to investigate the contact here, you're gonna just model this little bit, and you can go to more detail on this. So for here, we just going to pick this node as the source, and it'll grab all the nodes on those two edges. So we can use feature edge nodes, pick this edge, it'll pick those, and this edge. That's L-shaped nodes. As I said here, L edges should be edges of the link. Okay, then we're gonna put this RB2 in the correct collector, then say OK. Okay, now those nodes are fixed on the source node. We can turn on the C bar here. Now this RB2 and the C bar is not attached Okay, it's free to leave the screw. So we're gonna insert element, create a bushing. And now this C bush is different from our pin joints because this is a ball joint. So we're gonna create another collector with different properties, and this time we're gonna grab 2 nodes too. So pick first one, then click the second one, and OK. So as you can see, we don't see any SP showing up because that's in a new collector. So we're gonna right click the new collector, edit display, enable the text, and what color should we use? It's probably orange in the slides. So, oh, by the way, by default your SP will be pretty small. So if you want to change that, you can go to Preference. Yeah, I guess that's Visualization. And then here you have color and font. You can change the font size. Default is 10. You can change that to 18 and even bigger. Okay. Also different styles. Wow, too much. Okay. So well, remember we have to make this a ball joint by manipulating the stiffness of this C-bush collector. So edit this collector, edit the property of this collector. Then we don't want translation, so kill 3 degrees of freedom on those, then zeros for the rotation. Now this SP will rotate on X, Y, and Z, so it is a ball and socket joint. Okay, so that concludes the ball joint. Then, okay, remember to check the coordinate system. It's there, which is good. Okay, so you have to check it all the time because you never know when it will not automatically give you the coordinate system. Alright, so that's all the joints we have here. Now you can turn off the node display, so we can go to model display and change the marker to a dot. It'll give you a clear view of the meshes. So we have 3 pin joints and 1 ball joint here. If you turn off the meshes, it's gonna be like this, and we should have another spider here. Okay, and next, okay, that's red because I put in another connector. Doesn't matter. So next, the fan assembly is gonna be, I'd say 90% of the problem comes from the fan assembly, because you want to make sure this bar is not connected to this RBE2. Otherwise, it's not going to rotate. It's gonna fix over there. So how do we check those things? We have a tool called Show Adjacent. Okay. So here's the step. How do you use this tool? So we're gonna use this, the very first pin joint, as example. We can pick those and hide them, Control B. And I'm also going to hide the bottom of this joint, including the C bar. So, show adjacent, it's going to show, if you pick this element, it's going to show the element that shares nodes with this element, which means they use the same node. Which means if you pick a node, it's going to show the element that attached to this. So remember, we build the C bar directly on the source node of this RBE2. So if we use show adjacent, we should see the C bar showing up, right? So apply, and that's good. That's a C bar. And what are those? Those the elements on the grip. They are attached to the RBE2, or rather the RBE2 is grabbing them. So if you have any load on this end of the C bar, it's going to be transferred to the 2D mesh. All right, next step, what's attached to the C bar? And since the RBE2 is already on the screen, so it will not show up again. So if we hit apply, what you want to see, you don't want to see this RBE2, because whatever showing up now is going to be directly attached to C bar. So apply, which is good because that means those two sections of C bar is rigid connection, and the bushing is connected to the C bar. So we can consider C bush element has two legs. One is on the C bar, the other one should be on the pink RB2. So now we pick the SP. It's hard to pick this. You can just right click on the center, select from list. But we should have three elements, two elements of the C bars, and one in the middle is the SP, is the C bush. And apply, that'll give us the spider, which means the connection is from C bar to bushing to RBE2, now which is written here, from C bar to bushing to RBE2, which is good. The RBE2 is in the middle, acts as your degree of freedom. And we can say for the bottom and the bottom. If you're interested, you can do this for everything. It's gonna grow based on your element, what's attached to them. Okay, so that's a check for the pin joint, and you have to do this in your homework as well as in your report, and you cannot skip any steps. You cannot say, okay, I have one spider on the screen, then I use the multiple steps of show adjacent, then I got this. No, you cannot do that because I don't know how those things are attached. You have to do one step at a time for the screenshots. Okay, now, we need to turn this off. And after you use the show adjacent, the thing is gonna get weird. Let's say if you want to show the link, it's not showing up. You have to clear this again and show it. So you have to show and hide, then show multiple times to make this go back to the normal state. Okay, now let's check the screw. We can turn off the 2Ds. Where should we start? We can start from this spider. Okay. Then we can hide these and also the bushing. Alright, so this RBE2 represents the link. Show adjacent for this RBE2, and the link is not attached to, it's not directly attached to the screw, so you don't want to see the screw coming out. So apply, you see the link, you see that bushing, you see the degree of freedom is your bushing. Right, then if you grab the bushing, apply, you can see the screw. It's one section of the C bars. So if you pick this one, you should see not only the other section of the C bar, but also the spider, which means the spider is attached to this section of the C bar. So they are rigid connected. In this case, in the pin joint, if you pick this C bar, you will not see the spider come out, which means they are not directly connected. So they can rotate on the bushing here. Okay, so it's a little bit complicated, but once you get used to it and you practice a couple times, then you will get a feeling. When you look at this thing, you're looking at the pin and joint in the real thing. Okay, so another way to get rid of those weird display, you can just go back where you started, then you will behave better. Okay, so you should have those 4 joints done for this lab, and there is a comparison between sometimes it will happen. What will happen if your joint is not good? And you will actually see this in the simulation. You can see in simulation, if one of the joints was not good, either you get no results or you get a very funny results that you look from the top, the center spider is rotating, which is good, but if it's fixed on the C bar, it's gonna stay the same like this, and the good ones, they're gonna rotate. So you can tell from the results if one of that is not good. Alright, that's the homework. Pretty much the homework is covered in the video and in the slides, so you should be able to answer them. Alright, so practice and get to know the pin joints. Thank you.